Verkar presempienteron. Nam tofrenar den inom hikasa. Then start talking.
James Webb detected something it shouldn't. NASA, part of the data, then went quiet. Whatever 3IAtlas is...
A fast-moving object the size of Manhattan is tearing through our solar system, and it's not slowing down. It will make its closest pass to Earth on December 17th, moving at over 200,000 kilometers per hour. Astronomers call it 3IAtla. Officially, it's labeled a comet, but the data coming in tells a far more unsettling story. 3IAtlas was discovered on July 1st by the NASA-funded Atlas survey. At first glance, it looked like another interstellar visitor, similar to Oumuamua or 2I. But almost immediately, something felt off. This object wasn't behaving the way comets are supposed to behave. And then the James Webb Space Telescope started watching. James Webb wasn't built to study objects like this. It was designed to look deep into the early universe, to study the first galaxies and the echoes of the Big Bang. But when an interstellar object crossed into our neighborhood, science pivoted, and Webb's infrared instruments became our most powerful tool for understanding this alien traveler. At the time, 3IAtlas was positioned behind the sun from Earth's perspective. Ground-based telescopes were blind, overwhelmed by glare. Webb, stationed at the second Lagrange point far beyond Earth, had a clear view. For weeks, it quietly collected data, while nearly every other instrument couldn't see a thing. What Webb detected immediately raised eyebrows. Its spectrometers identified extremely high concentrations of frozen carbon dioxide, far higher than anything ever recorded in a known comet, even higher than 2I Borisov. The previous interstellar visitor in our solar system, cometary ice, is dominated by water. Carbon dioxide usually appears in smaller amounts, but 3IAtlas reverses that pattern entirely. This matters because chemistry tells a story. The ratio of carbon dioxide to water ice suggests that this object formed in an environment far colder, farther from its parent star, or under chemical conditions. Unlike anything we've observed before, this is a preserved sample of an alien solar system, one we will never visit. But the chemistry wasn't the only anomaly. Webb's data revealed a coma that was unusually stable. Most comets fluctuate wildly as jets turn on and off, responding to sunlight and surface irregularities. But 3IAtlas didn't behave that way. Its material loss appeared steady, controlled, almost regulated. Not artificial, but certainly unusual. Then came the pulse. Every 16.16 hours, the object brightens and dims with extraordinary precision. This isn't random flickering. Multiple observatories, including data from amateur astronomers using stacked photometric measurements, confirm the cycle. Scientists call this a rotational light curve. Many objects spin, most wobble, most tumble. This one doesn't. Its rotation is smooth, exact, consistent like a ticking clock. That level of regularity is rare in natural objects. When it does appear, it's usually associated with engineered systems. Even stranger, the pulse is linked to gas jets erupting from beneath the surface. But these jets shouldn't exist when they do. On typical comets, outgassing peaks near the sun when heat activates surface ice. 3IAtlas began strong outgassing long before perihelion, when it was still extremely cold. And it has continued long after. The timing makes no sense. The content of the gas only deepens the mystery. Spectroscopic data shows unusually high levels of methanol and hydrogen cyanide molecules considered prebiotic. These are the same chemicals scientists believe played a role in the origin of life. Hydrogen cyanide can participate in reactions that form amino acids, the building blocks of life. These aren't trace amounts. The methanol concentration is several times higher than what we see in comets from our own solar system. It has a rich chemical stew that shouldn't exist in these proportions unless it formed in an environment very different from anything near our sun. Some astronomers argue this proves how chemically diverse the galaxy is, that interstellar objects will naturally look strange to us, and that might explain everything, if the anomalies stopped there. They don't. 3IAtlas is accelerating in ways that cannot be explained by gravity alone. This is known as non-gravitational acceleration. Comets can experience it due to asymmetric outgassing. But the force required here doesn't align with the observed jets. Even more puzzling, its spin rate isn't changing. Outgassing should gradually alter rotation. Jets push unevenly, slowing or speeding an object over time, but 3I Atlas remains locked at the same rotational speed, almost as if it's self-growing. Taken individually, each of these traits might be dismissed as an outlier. Together, they form a profile that refuses to behave like a natural comet, which raises an uncomfortable question. If the data is this strange, why isn't NASA saying more? The truth is, NASA isn't silent. It only feels that way. Officially, both NASA and the European Space Agency classify 3IAtlas as a comet. Highly unusual, but natural, and that decision has fueled massive online speculation. James Webb data doesn't go straight to the public. It's calibrated, rechecked, and reviewed by multiple independent teams. These instruments are so sensitive that a single error can completely distort conclusions. Scientists move slowly because credibility depends on caution. There's also history. When Oumuamua passed through our solar system, some researchers, most famously Harvard astrophysicist Avi Loeb, publicly raised the possibility that it could be artificial. The media exploded. NASA was forced into damage control. That experience changed everything. Now, even with more than a dozen anomalies tied to 3IAtlas, the pulse, the chemistry, the acceleration, the early outgassing, each finding is presented separately. The dots are never officially connected. Outside the agency, however, the conversation is shifting. A small but growing number of researchers are asking whether this object is only pretending to be a comet, whether beneath layers of ice and dust there could be structured function, design. The idea isn't new. Models already exist for ancient, derelict probes drifting between stars, collecting debris over millions of years. Entering a solar system, sunlight heats the surface. Ice sublimates, jets fire. To most instruments, it looks exactly like a comet, but underneath, something else could remain. In this scenario, the regular rotation isn't accidental. The acceleration isn't natural. The jets aren't random. Even the absence of visible thrust could be explained by scale, small, directional emissions. Beyond current resolution, the key test lies in particle velocity. Natural outgassing produces speeds of a few hundred meters per second. Technological propulsion would produce far higher velocities in precise directions. Measuring that requires extreme resolution and long observation windows, something we may not have time for, because 3IAtlas is already leaving. It's on a hyperbolic trajectory, escaping the sun's gravity entirely. In the coming weeks, it will fade below the detection threshold of most Earth-based telescopes. Only space observatories like Webb will catch its final emissions, and then it will be gone forever. No rapid response interstellar program exists. No standing protocol to redirect probes or prioritize these once-in-a-generation events. By the time committees decide, the opportunity is already slipping away. If 3IAtlas is natural, then our understanding of comets just changed forever. If it isn't, then humanity may have already encountered evidence of another civilization and failed to fully recognize it. Either way, this object came from somewhere else. It behaved in ways we do not yet understand, and it is disappearing into the dark.